we're going to tell you about the things like reflection and refraction of light waves with their angles properly and stuff. Like, what is this whole stuff and Snell's law and everything, refraction and reflection? What is reflection, by the way? What's refraction? Reflection is just like you're having a light on any plane mirror, and it just reflects back. Like if you're standing in front of a mirror, your whole light from your body will be transmitted onto the mirror. Like whole will be theirs. But if you're gonna insert a light on the your mirror, then it will be reflected back there. Okay, whole will be reflected back. Some will be absorbed, but mostly will be sent back. Okay, so how it's gonna work now? Let's say we're having a plane mirror. We are gonna incident any rays like any wave, any light, and it there's a normal. Let's draw a normal like 90-degree, just for assuming it, and then whole incident ray will be equal to the reflected ray. Like whole incident ray intensity will be reflected. Okay, so on a plane mirror. So I is the angle of incident and R is the angle of reflection now. So law of reflection, what's the fucking law of reflection now? Law of reflection is like I, R, and normal must slide on this plane. On the same plane, they all will be like, they will not be out of the plane. Like when I say is I and R, like the angle of incident and the angle of reflection, and this whole plane, this normal will be on the same plane. And another law of reflection is like I is equal to R. Like both the reflection and refraction angle will be equal. This is the law of reflection now. Okay, this is how it works. This is the first topic. So now we're getting for refraction and stuffs now. Now we're gonna know about refraction of light wave. What is the refraction? Refraction means if you're gonna have two medium, like firstly light is in the air, then it's gonna pass from air to the glass, or firstly it's in another material, then going into another. This is no refraction. Like it's not from the mirror, but it will be from one medium to another, depending on change in direction of light when going from one medium to another. Like let's say there's air and then it's going into the glass. Like incident rays, they're like from the air it's going to the glass now. So it's the normal. We're going to draw the normal, by the way. It's the incident ray, and then it will be refracted. Refracted means that it will be refracted here. This is the refracted way, this is the refracted way, and this is the whole the normal here. So I will be the incident angle as usual, R will be the refracted angle as usual, and there was reflection angle, and this is a refraction angle. Okay, so refraction occurs due to velocity of light. Like the velocity of light will change here. When medium will be denser, velocity will be less. Like it is the more denser, like glass is more denser, so velocity will be less. Okay, and air is like less denser, it is rarer, and the glass is denser. And the when medium will be less denser, like it will be rarer, then the velocity will be higher. Okay, so it's the concept here. So like incident being plotted here, and then it will be refracted. How we get to know that it will be refracted towards the normal or away from the normal? Towards normal will be always when there will be less velocity. When the velocity will be less, which means less velocity means that it will be um, more denser. When the material will be denser than the one it's coming from, like it's coming from the air into the glass, which is more denser, then it will be bended towards the normal, like it's towards the normal now. Otherwise it will go like this in this way. Okay, so this incident ray, this is refracted way. And when velocity will be higher, it means this is rarer, it's very easily going through the things the light is, and it really means that it will be away from the normal. I is equal to angle of incident, and R is equal to angle of refraction as usual. Okay, so now we're going to study about the law of refraction. Now we're going to study about law of refraction. Law of refraction, as we study refraction, it means I, R must be opposite side of normal, all three lines on same plane. Like I and R must be opposite, like as we saw the I and R are opposite. Like I if it is here and the R is just opposite to it. And in the reflection, I is here and the refraction angle is here, like both are equal, and they both are on the same sides. And here the second rule, the sine of I by sine of R is equal to constant, which means the incident angle and refractive angle will have the sine proportional here. Okay, so what's the refractive index of a medium? Let's study refractive index of a medium. The extent to which the refractive medium increases or decreases the speed of light. Like any medium is gonna increase or decrease light speed. Why it's gonna decrease it? If it will be denser medium, it means we'll have more particles which will be very aligned different way. More particle will be there, they will be very aligned and stuff. It means it will decreases the speed of light. And when there will be rare medium like air, it's the particle here, particle far away, then it will decreases then it will increases the speed of light. As we know, the refractive angle is equal to n by 2 1 is equal to speed of light in the incident medium to the refractive medium. Let's say incident is like air and refractive like glass, so both proportional, both deviant will be theirs, like speed of light in, or we can say the speed of light in incident medium, like medium 1 and medium 2, and v1 or v2 is equal to n by 2 1, like both are equals, and 2 1 is equal to v1 by v2. Now let's study about Snell's law. What's the Snell's law? Snell's law is like we study the proportion like sin as by sin r, which will be equal to n to 1. As we also studied v1 by v2, both are equal. So what is n1? N1 is just like refractive medium of 1, which will be equal to speed of light by v1, and n2 will be c by v2 as normal. Let's say an example now. Light entered from air to glass having refractive index 1/50. What is the speed of light in glass now? The speed of light in vacuum is like this. So the first medium is like air, the light entering from the air to the glass. The one is medium 1, one and medium 2, and to 1 is equal to 1/50 as we studied. The glass is there. So how are you going to do the things now here? Here's the thing. N2 is equal to V1, V2 as we studied is equal to 1/50 as it's given the glass. So V1 is speed of light in air, the first medium. The v2 is the speed of light in glass, the second medium. What's the v2? We don't know the speed of light in glass actually. Really don't know the speed of light in glass. So we're going to do the things like if we don't know the v2 or like v1 in glass we know, but in air we don't know the speed of light. So we're going to just take it away like we're gonna just change it. V2 will be here, and to 1 will be here, so and to 1 will be already know 1/50, and v1 will be speed of light but in air. Speed of light in air is approximately equal to 1 multiplied into 10 raised to power 8 meter per second. We're gonna do some simple mathematics. We got 2 into 10 raised to power 8 meter per second as equals v2. Like the speed of light in glass will be like this one. So we can calculate in this way, and this is our whole concept of reflection and refraction of light waves and stuff. Thank you.